Okay, YouTube, in this video we're going to emphasize the even and oddness of some of our trig functions and how it's kind of beneficial when it comes to helping us evaluate them. So let's just go ahead and start by redefining what we mean by even and odd functions in the first place. So we've seen that a function is even if and only if, as a matter of fact. We say f of negative, and we're going to say input, we'll use a t in this case, is equal to f of t. That is to say, when you plug in a negative input, you'd get the same thing as if you just plugged in a positive input anyways. And so we'd say that this is an even function. And with respect to an odd function, in the same instance, when we plug in a negative input, we say f of negative input, which in this case we're using a t, what we end up with is equal to negative f of positive t, or the exact opposite of what we started with. So with respect to these two definitions, we have to understand that cosine is a function, sine is a function. Sometimes we are going to be plugging negative angles into them. And so negative angles, they rotate clockwise here. I would just like to say that when one has an opportunity of working with a negative angle or a positive angle, in an instance where you might be getting the same answer anyways, it'd be more beneficial to work with a positive angle. So what we're going to do is we're going to look at the values of cosine of a negative angle and sine of a negative angle and see if we can determine anything about their values that would allow us to say, well, instead of looking at a negative angle here, could we have looked at something else instead? So let's start with this. We have 2 points on the outside of our unit circle here. I would just want to emphasize this here. This is the circle of radius 1. We can see that this is the unit circle here. So what that means is that we have some point on the exterior here. We're going to say this is some x and some y. And we have some other x and some other y down here. As a matter of fact, just to emphasize this, I'm going to write this is x and this is the negative of this y value up here. Knowing what we know about the unit circle, this is our angle here, t, and let's do the exact opposite of this angle here. We'll do negative t. But what we know is this. We know that the cosine of t is this x value that you see right here. And we're also aware that on the unit circle, the sine of the angle is this y value right here. So it's very fair to say that the point P tells us both the cosine of t and the sine of t. Now on the point Q, interesting story is this. We have the cosine of negative t and the sine of negative t, and I am going to write that down here. We say that the x value here would represent the cosine of this negative t. So we'd say cosine of a negative angle, negative t, is our x value. And then we have sine of a negative t here. And so we'll build our arguments from this, sine of negative t here. And so the interesting thing is this. We know that x is equal to the cosine of t and y is equal to the sine of t just by looking at these two values right here. But when one looks down here, what we see is that x is also equal to cosine of negative t, and we see that negative y, I'm just borrowing this from right here, we say negative y is equal to sine of negative t. And so the first thing I'm going to start with is this. If x is equal to cosine of t, and x is also equal to the if x is equal to the cosine of negative t and x is equal to the cosine of positive t, then what this means is that the cosine of negative t and the cosine of positive t are the same. With respect to even and oddness, what we're really saying is with a negative input here, we got this. We got f of a positive input, which would indicate that cosine in our instance here has to be an even function, because when we put in a negative, we get the same thing as when we put in a positive in the first place. So when we look at a negative of t here, when we plug it in for sine, we get negative sine of t, and essentially what we're saying is this. If y is equal to the sine of t, and that's what our y value up here is, then the sine of negative t is we got negative y. So that is to say that we got negative y, and y is the sine of t. That is to say, in a long story short situation, sine of negative t is equal to negative y, which is negative sine of t, which would indicate that this is an odd function. F of negative t is equal to negative f of positive t. And so, what we want to know basically in this video is this. We want to be familiar with the fact that of all 6 of our trig functions here, and one thing I want to kind of elucidate upon here is this. You see the original relationships over here. Everything over here on the right, these are just the reciprocal relationships. But it's worth noting here that cosine, we determined cosine was an even function. And because it is even, also its reciprocal secant is even. That is to say, if anything's even, your reciprocal's even. If anything's odd, then your reciprocal's odd. So that being said, since cosine is even, we say everything else is odd. Everything else is odd, with the exception of being secant, which is its reciprocal. So we say sine of negative t would be the same thing as negative sine of t. And then tangent of negative t would be negative tangent t. Essentially, you see that with odd functions, this negative moves out in front. And so what this does in every possible instance, you can see that we're taking a trig function of a negative angle, negative angle, negative angle, negative, negative, negative. We could always rewrite it as having a positive angle as an alternative, which is, valuable. So in other words, let's just take a look at an example here. What if we were to look at, say, the cosine of a negative 60-degree angle or the tangent of a negative pi 6 radian angle? What this allows us to do is to rewrite the trig function having positive angles. Trig function as having a positive angle because, well, we like positive angles. And it would mean the same thing anyways. So cosine, since cosine is an even function, we know that when we plug in a negative here, it would be the same thing, is that negative simply disappeared because f of negative t is the same thing as f of positive t to begin with. So whenever we take the cosine of a negative, we can lose the negative. This is true with cosine and its reciprocal secant. So with respect to this, we could say, well, then it's the same thing as the cosine of 60 degrees. And the cosine of 60 degrees, that would have to be the same as the sine of 30 degrees. But we would end up with just a half there. So we say a half. And then with respect to our tangent of negative pi 6, I'm going to pull this down over here, but the tangent of a negative pi 6, because tangent is odd, it's an odd function, that means f of negative t is the same as negative f of positive t. We're going to take that negative and we're going to pull the negatives out front. And so what this allows us to do, again, is to rewrite this instead of tangent of negative pi 6. We can do a negative out in front and do the tangent of just a positive pi 6, or negative tangent if we're doing this in degrees. A sixth of 180 would be 30 degrees. And so our tangent of 30 degrees, tangent of 30 degrees, of course, is root 3 over 3. But we get negative root 3 over 3, and that would be the same as the value of the original thing in the first place. So the benefit here to knowing whether or not your trig function is even or odd is if ever there is an instance where you're plugging in a negative angle, you can rewrite it as having a positive angle instead. Cheers.